Hi. So another projectile sum. Okay, this is from June 2015 GCE, question number 18. So a student investigated the physics of football. She used the equation of motion to model behavior of the ball when kicked at different angles to the horizontal. Okay, so when you kick the ball at different angles, okay, for example, at this angle or this angle or this angle, when you kick the ball at different angle, equation of the ball, okay, she predicted the height of the ball when it reached the goal presuming it was kicked from the same place with the same initial speed each time. The results are shown in table below. Okay, so you can see there is a negative sign over here. So I'll tell you what is the meaning of this negative sign sometime later. So when it was 20 degree, it was 1 meter from the goal. Okay, height of the ball, the height was 1 meter from the goal. When it was 30 degree, 22.8 meter from the goal, and 4.7. These are vertical height, I think. Height of the ball when it reached the goal. Yeah, I don't understand how did they remain in air though. That is confusing for me. It is supposed to hit the ground, right? Okay, whatever. State the significance of the negative value of the height. Okay, now, so what is the meaning of negative value? The word negative value means the ball actually traveled below from the height it was kicked from. Like for example, if the ball was kicked from here, okay, it went 0.78 meter below from where it was hit. So if it reached here, s would be 0 because it was kicked from here, so s also 0 over here, and it came back, but here it went below according to this. So if you see the mark scheme properly, they wrote over here the ball would be below the initial height from where it was kicked from. Okay, I hope you guys understood that. Now if we go to the next question, on the diagram below, sketch and label predicted path at 20 degree and 40 degree. So you can see at 20 degree it's 1 meter from the goal, and at 40 degree it's 4.7 meter. So if we draw the projectile path, the predicted path, let's say at 20 degree approximately, I don't think so we need to do it with the help of projector. You know what, better you guys do it with the projector. Let me do with the normal over here. So here it was around, okay, this is a bad diagram. Okay, so this is 1 meter from the ground, 1 meter, this is 20 degree, let's say. Okay, 1 meter from the ground, and if you throw something 40 degree, this is how it's going to be. This is 4 meter from the ground. Okay, and this is 40 degree. Okay, so this question is also done. 2 marks over here and 1 mark from here. You have to say the ball traveled below initial height it was kicked from. Okay, so now next question. Yeah, now this is the main, the calculation part. During football match, the ball is kicked towards the goal, okay, at an angle 15 degree, and no data of 15 degree has been provided to us on top. We will do calculation. The horizontal distance, see they gave you horizontal distance, that's a hint. Whenever horizontal distance are given, in your mind it should be s equals to horizontal velocity into time. This should go on, because since it's horizontal distance, it has to be horizontal velocity, and for horizontal velocity and horizontal distance there is only one formula. I mentioned this previous videos as well. The ball has a diameter of 0.22 meter. Very important point. We have to keep this in mind. An initial speed of 26 meter per second. Initial speed of 26 meter per second. Whatever. By means of calculations, determine whether or not the ball will pass into the goal. Okay. So if the if the ball travels like this, definitely it's going to miss. But if the ball travels like this, it's going to be a goal. If it can touch the bar also. Okay, you must have seen in many football games where the ball touches the bar and comes back. I think that is the reason they gave this to 0.22 meter, because let's see how high did the ball go. If the ball's height is vertical height, so vertical velocity is definitely at play here. If the vertical height is more than 2.4 meter, it's not going to be a goal. But if it is less than 2.4 meter, it's going to be a goal. And if it is equal to 2.4 meter, most probably it will touch the bar and return back. Okay, so let's see. So what did they mention? They gave us the initial velocity. So we know horizontal velocity and we know vertical velocity. Horizontal velocity is 26, 26 cos 15 degree, and vertical velocity is initial vertical velocity is 26 sine 15 degree. I hope you guys know that opposite of the angle is always sine. So vertical velocity is sine and horizontal velocity is cos. Okay, this is u cos theta, horizontal velocity, so uh cos theta, uv sine theta. Don't write over here in the examination. Okay, now uh, okay, by means of calculation determine whether the ball will pass. Okay, let's see how long did the ball travel, for how long the ball was in the air. Okay, you know the horizontal distance traveled, okay, is 11 meter. So let s be 11 meter, and we already know. So there is only one question that suits us, that I discussed over here, s equals to into t, because since it's about horizontal velocity, we have to use horizontal velocity equation. There is only one equation for horizontal velocity. Okay, so how much is going to be? 11 is equal to 226 cos 15 into time. Okay, so time equals to 11 divided by 26 cos 15 degree. Okay, so let's see how much is that. 11 divided by 26 cos, make sure your calculator is in degree and not in radian. Okay, if you don't know what radian is, ask your teacher. 11 divided by, okay, 0.438 seconds. So the ball traveled for 0.438 seconds horizontally. That means it also travels 0.43 seconds vertically. That means the ball was vertically here. Let me rub them. Okay, so the ball was vertically here and it traveled 0.48438 seconds. Was it? Yes. So how much height did it attain at that point? How much height did it travel? What is the initial vertical velocity? Initial vertical velocity is always the vertical velocity from the angle which we get. That is going to be 26 sine 15. So initial vertical velocity is 26 sine 15. It was going up. So therefore acceleration is minus 9.81. What time was it traveling for? It was traveling for 0.438 seconds. So I need to find vertical height. That is going to be S again, but this is the vertical height. Okay, question mark. S vertical, I can give shortcuts. Okay, SV vertical height. So initial, final, don't take final velocity as 0, because we don't know whether it has reached maximum point at over here or not. We don't know. We only know the initial velocity. Okay, with the help of initial velocity I can make an equation. Which formula suits us the best? S equals to ut plus half at square. Okay, so S vertical we need to find u 26 sine 15. Let me do that in calculator. 26 sine 15, that's going to be 6.729. I'm taking more numbers over here. 6.729 into 0.438 plus half a is minus 9.81, okay, into t square, that is going to be again 0.438 whole square. Okay, so let us do it slowly. 6.729 into 0.438, how much is that? 2.947, 2.9473. I'm taking more decimal numbers so that I get an accurate answer, and finally I will make it either two significant figure or or three significant figure. 0.5 into 9.81 into 0.438 whole square in calculator, that's 0.940, but it should be minus 0.94099. Okay, so how much will that be? 2.9473 minus 0.94099, it's around 2.00, that's around 2 meter. But I need to add even the diameter of the ball also over there, because that plays a role. So 2.0.22 meters, so it's going to be 2.2 2 meter. Okay, so which is less than 2.4 meter showed over here, which is less than 2.4 meter. Okay, so therefore yes, the goal is scored. Okay, let's see the mark scheme what they wrote over there. Okay, the height is 2.23. Okay, so the height of the top of the ball. Okay, what did they say? They didn't mention. Answer to be consistent, this is less than 2.4 meter and the goal will be scored. Okay, I hope you guys understood the question.